A school has invited 42 mathematics teachers, 56 physics teachers, and 70 chemistry teachers to attend a science workshop. Find the minimum number of tables required if same number of teachers are to sit at a table and each table is occupied by teachers of the same subject. See, same number of teachers to sit on each table. So here, from this we can conclude that we need to find HCF of 42, 56 and 70. So this will give us the number of teachers to be seated in each table. Then how many tables? Then we can divide that number, like 42 by that number of teachers on each table, 56 by number of teachers on each table, 70 by number of teachers on each table will give the number of tables. So first we'll find HCF of 42, 56 and 70. So 42, 56, 70. See, 42 prime factors: 2 times 21, 3 times 7. So 2 into 3 into 7. Then 56, 2 times 28, 2 times 14, 2 times 7. So which is 2 cube into 7. And 70, 2 times 35, 5 times 7. So that is 2 into 5 into 7. So HCF of 42, 56, 70 is, see here, HCF definition is product of common prime factors. So here we have common prime factor is 2 and 7. 2 and 7 in all the three we have 2 and 7. So the HCF is product of common prime factors with the least power. Here it's 1 and it's 7. So HCF is 14. Now find the number of tables required. So for tables required, what you do is HCF is 14. So number of tables required for mathematics teachers is 42 by 14. So 3 tables are required for mathematics teachers. Next, physics teachers. Physics number of teachers are 56 and on each table 14 teachers will sit. So we need 4 tables for physics teachers. Next, for chemistry, total number of teachers 70. On each table 14 teachers will sit. So it is 5. So number of tables is total number of tables required. Total number of tables required. Three plus 4 plus 5, which is nothing but 12. 12 tables are required.